Well, we know that there's actually a remarkable variety of molecules in the universe. Chemists didn't expect that at all, because the interstellar space is very tenuous. There's a lot of UV radiation. A molecule meets another molecule maybe once every 10,000 years. So chemists were not expecting there to be a lot of chemical richness. But now we know actually that there is an enormous variety of species there. More than 180 different molecules have been detected, ranging from very simple molecules like carbon monoxide, water, of course a very important molecule, to also rather complex organic molecules, dimethyl ether, methyl formate, even simple sugar molecules like glycoaldehyde. Well, the Atacama Large Millimeter Array, ALMA, is going to be really a major advance for the field of astrochemistry, and that is through a combination of two aspects. First of all, it's incredibly sensitive because it is an array of more than 60 dishes that combines the signals on a source, but at the same time it can also image the source, and it can really zoom in at much higher spatial resolution than we've ever been able to do before. So previously we were looking on very large scales of entire molecular clouds or cores, and now we're able to zoom in with ALMA really on the sites where at this moment star and planet formation is occurring. We observe various molecules that are actually important for the origins of life. Water is obviously a key molecule in this because nobody has yet found a way to make life without having at least water involved. So thanks to the Herschel Space Observatory and also some other missions, we now know that water is abundant in the universe. It's actually most abundant as ice on the tiny dust grains, and that water is actually available in all different sites of star and planet formation. But we also find other prebiotic molecules, and prebiotic means in this sense molecules that could be important for building, say, DNA or RNA eventually. So here we think about sugars, like this simplest sugar, glycoaldehyde. We think of amino compounds, of which several have been found already. And people are now going to use ALMA in order to search for the simplest amino acids, like glycine, for example. Well, ALMA is still reaching its full capabilities. It's not yet there. It's still in the initial phases. But this one fantastic image that I showed this morning of this forming planetary disk, with all these rings and gaps in there, that's already a hint that we are now really starting to resolve the regions in which planets are being formed at this very moment. And if we then can also determine the chemical inventory of these planet-forming sites, then I think we'll be making a major step forward towards our origins. If there's one thing that we have learned from the data so far, then it is that water and complex organic molecules are present near virtually every star that is forming in the galaxy, and presumably even beyond the galaxy. If we can now also zoom into the planet-forming sites, then we come yet closer to our own origin.